You are welcome to the Scholar Online class.
The Scholar School will establish our footprints on the sand of time. You can't afford to miss any bits of this class. Experience the difference.
Welcome to the online scholar class. My name is Abdulwasi Abdurrahim. I'll be your mathematics tutor, and today we'll be looking at our topic, bearing and distances. But before we go into bearing and distances, let's try and refresh our memory on sine and cosine rule, because this is the foundation of bearing and distances. So I'm going to take you through sine and cosine rule first. Sine rule. Now, you know that when you have to solve any problem regarding any triangles, we have different methods in which you can apply. Is either you apply Pythagoras theorem, you apply the Socrates, you apply sine rule, you apply cosine rule. But sine and cosine rule are applicable to triangles that are not what? Right angle triangle. And that's what's basically what we'll be having in most of the questions under bearing and distances. So when you talk about sine rule, given triangle ABC, ABC, these are the angles. Why the sides are represented with what? Small letter. So if this is C, the side opposite C is small letter C, the side opposite A is small letter A, and the side opposite B is what? Small letter B. So in any triangle of this nature, you must have the angles and the side. So give me a triangle of this nature, and you are using your sine rule. So the law states that our side A over sine of the angle is equals to our side B over sine of the angle is equals to our C over sine of the angle, which is C. Or we can have it what? We can reciprocate what we have here as sine A over small a is equals to sine B over small b is equals to sine C over small c. So you can only use two ratios at a time. You cannot use the three simultaneously. So you can only use two ratios at a time. Now, what are the conditions for us to use sine rule? Let's look at these two triangles so that we take the conditions for using sine rules. Conditions for using sine rule. Let's look at these two triangles. ABC. This is 60 degrees. This is X. This is 10 centimeter. And this is Y. And this is 40 centimeter. So if you look at this triangle, we are given what? One side out of the three. And we are given how many angles? Two angles. So when you are given two angles and one side, that is the first condition for using sine rule. The first condition is what? When two sides are given. When one side and two other angles are given, then we make use of what? Sine rule. Remember that the side that is given, the other side is not given for the angle that you have in between the side. So when the one side and two angles are given, then we make use of what? Sine rule. So let's look at this now, using the formula we have on the board. Using this triangle to solve, applying the formula here. I'm asked to find x and y. As long as we have to find x and y. From this diagram here, our angle A is equal to 60 degrees. My small a is x, right? Our angle B is equal to 40 degrees. My small b is equal to what? 10 centimeter. Our angle C is unknown. My small c, which is y, is also unknown. So if you look at the two known, these two are known. The side and the angle are given. So I can combine this and this one so that I can get my x. So I'm combining A and B now. So from what we have, it means I have sine A small letter a over sine A is equal to small letter b over sine b. My small letter a is x. Sine A, that is sine 60 degrees. Because of small letter b, that's 10 centimeter. Sine b, that is sine 40. So you can see that the only unknown is what? X. So when you cross multiply cross multiply is what? This will multiply this will multiply this. So I have what? X times sine 40 is equals to 10 times sine 60 degrees. I'm looking for x. X is equals to what? 10 sine 60 divided by sine 40. So that gives us our answer for x. Similarly, if I've gotten that, then I can get my y. Remember that this is a triangle. And we know that in a triangle, our angle A plus angle B plus angle C is equals to 180 degrees. Why? That is sum of angles in a triangle. So that means angle A, which is 60, plus angle B, which is 40 degrees, plus angle C, which is unknown, is equals to 180 degrees. So from there, I can get my angle C. It means that angle C is equals to 180 minus 40 plus this is 100. And our angle C will be what? 80 degrees. So if I want to get C, which is y now, I can still apply this as what? Our C over sine C is equals to what? A over sine A. My small letter c, which is y, sine C. Sine C is what? Sine 80 degrees. Is equals to small letter a, which is what? X. And that's what I've calculated. Or let's even use b. Small letter v over b, since that one is known. So my b is what? 10 over sine 40 degrees. So when you cross multiply here, you also get our y. So that means our cross multiply y is equals to what? 10 sine 60 all over what? Sine 40 degrees. And that gives us our y as well in centimeter. So the first condition for using sine is that what? One of the sides must be known and two angles must be given. The second condition for using sine rule. Condition number 2. Let's say I have A, B, C. Are you with me? Let's say this is 6 centimeter. This is a 12 centimeter. And this angle here is 60 degrees. One angle and two sides. The first one, two angles and one side. The second one here now, one angle and what? Two sides. So when one angle and two sides are given, then you see applies sine rule. So for this one, based on what we have here, this is my small a, this is my small c. So I have a and c, and I have the angle. So I'll be having what? A over sine a is equals to what? C over sine c is equals to b over sine B. So let's say you have to find angle B or angle C here. You can use this ratio. So using the first two ratio, my A is what? 12. Sine A, that's sine 60 degrees. And my C is what? Our C is 6 over sine C, unknown. So you can see that this is unknown here. Only one unknown. So if you cross multiply, we have 12 sine C is equals to 6 times sine 60 degrees. Then divide both sides by what? By 12. Is equals to 6 sine 60 divided by 12. So therefore, our sine C is equals to 6 sine 60 over 12. And that means sine C is equals to 6 times sine 60 is root 3 over 2 divided by 12. So sine C is equals to 2 in 6, that's 3 root 3 over 12. Sine C is equals to 3 in 12, that's 4 root 3 over 4. And sine C is equals to square root of 3 is 1.732 over 4. So C is equals to arc sine That means shift, then you press sine of this 1.732 divided by 4, which means our C is equal to arc sine 0.4 in the 4 in 17. That's 4 remainder 1. 4 in 13. That's 2. Remainder 3. 4 in 32. That should be 8. So that is it. So, and from there you get your C. So the two conditions for using sine rule are: number 1, when two angles and one side is given. Number 2, when two sides and one angle is given. Then that you should know that you have to use what? Sine rule. I hope that is clear. Let's go to cosine rule. Cosine rule. So for our cosine rule, so let's say you are given a triangle ABC. ABC with side small a, small b, and small c. Now, according to the cosine rule formula, then the first one is going to be what? When you take the side, then you take the other side. So the square of the first side, a squared, is equals to b squared plus c squared minus 2bc cos the angle. Cos the angle. Then if I take the next ratio, b squared, since I'm taking b, it's going to be remaining what? A and c. A squared plus c squared minus 2ac cos the angle, that's b. Then if I take c, it will remain what? A and b. So c squared is equals to a squared plus b squared minus 2ab cos the angle, which is c. So this is our cosine rule. So what are the conditions for using cosine rule? Let's look at the conditions. Number 1, when one angle and an enclosing, when two sides and an enclosing angles are given. That's the first condition. Two sides and an enclosing angle is given. So let's look at diagram. Let's say you have a diagram of this nature, ABC, or let's even take it to PQR. PQR. This angle, let's say this is 60 degrees. This is 6 centimeter. This is 12 centimeter. And that's why you have to find X, find angle P, and find angle Q, R. So in this case, you see that we are given two sides. The first side is it QP, the second one is what? QR. These two sides are what? Enclosing the angle of what? Angle Q, which is 60 degrees. Compared to for sine rule, which the side that is given is what? Is not enclosing the angle. Look at this diagram here. The example here. You see that these two sides, do you have any angle there? Of course not. So in this case, you use sine rule. But when you have two sides and the angle is in between the two sides, automatically you have to use cosine rule. So for here now, if you have to find X or find any of the angle, we apply cosine rule. So if this is Q, this will be small letter Q. R, small letter R. P, small letter P. So since I'm to find my small letter Q, then following the same formula, you can use any letter. It's going to be what? Q squared. Since I've taken Q, it's remaining what? R and P. Is equals to R squared plus P squared minus the products. That's 2RP, then cos the angle, which is what? Q. And that is the formula. So it's not compulsory, it's A or B or C. It can take any trend. So let's substitute now. Means I have Q squared is equals to my R is what? 6 squared. P is what? 12 squared. Minus 2 times 6 times 12 times cos Q is what? Cos 60 degrees. And that means I have Q squared is equals to 36 plus 144. The square of 6 is 6 times 6, and 12 times 8 minus 2 times 6, that's 12. 12 times 12, 144 times cos 60 is what? Half, or 0.5. So that gives me Q squared is equals to 144.36. 0 8, that's 180 minus, this is 2 in 14, 72. So Q squared is equals to 180, 72, that gives us 801, 108. So therefore, Q is equals to square root of 108, and that gives us our answer in centimeters. So this is the first condition for using cosine rule. Then the second condition for using cosine rule is what? When all the sides are given and note angle. When all the sides are given with no angle. Let's look at that here. So I have M, N, let's say P, M, N, P. This is 3 centimeter. This is 7 centimeter. This is 13 centimeter. In this case now, none of the angles are known, but the 3 sides are stated. So when you have something like this, automatically you are going to use what? Cosine rule. So if I'm to find angle either M, angle N, or angle P, I'm going to use cosine rule. So let me start with, assuming I'm to find angle M. To find angle M. So you focus on that. M will be this small letter M, this is small letter N, and this will be small letter P. So since I'm looking for M, the M will come first. So I have M squared is equals to what? N squared plus P squared minus 2NP cos the angle M. So which means I have M squared, which is what? 7 squared is equals to N, that is what? M is 13 squared, sorry. 13 squared is equals to N is what? 7 squared plus 3 squared minus 2 into 7 into 3 cos M, which was what I'm up to. So 13 squared means 13 times 13, that's 169, is equals to 49 plus 9 minus 21 times 2, that's 42 cos M. So I have 169 is equals to 49 plus will give us 58 minus 42 cos M. Mind you, you cannot subtract this because this one is attached to this. So the next thing you collect like terms. So I have 169 minus 58 is equals to minus 42 cos M. So if you subtract this 169, 58, that's 111. Minus 1, okay, 111 is equals to minus 42 cos M. So therefore, make cos M the subject formula. Cos M is equals to 111 divided by minus 42. And your M will what? Inverse of 111 over minus 42, which will give you what? Your required angle for M. So this is all about the sine and cosine rule. I hope that is taken, because this is what you are going to use when it comes to bearing and distances. So let's now move into bearing and distances properly. So when we talk about bearing and distances, it is an aspect of mathematics that is very, very important when it comes to measurement of land space or land area. For example, the people in the surveying industry require the knowledge of bearing and distance. The geographers require the knowledge of bearing and distances. The pilots require the knowledge of bearing and distance. The sailors require the knowledge of bearing and distances. Then the people in the military also require the knowledge of bearing and distances. So you can see that the knowledge of bearing and distances, you cannot discountenance it. So when we talk about bearing and distances, bearing is the measurement of what? Of the area covered with respect to what? The angle through which what? Through which you move. The area covered, or the area in space or region, through what? Through what? An angle. So under bearing, we have two types of bearing. We have two types of bearing. The first one is what we call the two-digit bearing. The two-digit bearing or compass bearing. And the second one is what we call the three-digit. The three-digit bearing, which in other contexts we also call it the sailors, just like I stated earlier, the sailors or the army and the rest of it, or the military bearing. But the official name is what? Three-digit bearing. Now, starting with the first one, two-digit bearing or compass bearing. As we all know that in nature, from the globe, we have basically 4 cardinal points. Four cardinal points: the North Pole, the South Pole, the West Pole, and the East Pole. These are the 4 cardinal points. Which means that, and you know, since it's a rotation, it means forming what? An angle of what? 360 degrees. So it means that each angle between them is what? 90, 90, 90. Forming a what? A total revolution of what? 360 degrees. So this is what we mean by cardinal points. So these 4 cardinal points, this is 4 cardinal points, can be further divided to what? 8 cardinal points. Eight cardinal points, just like I have here: north, south, west, and east. Now, if I take a line from this way and divide it into 2 equal portions, then take another one from here, divide it into 2 equal portions, then I've succeeded in dividing it. So since it's what? A perpendicular, a direct bisector, it means each angle will be what? 45, 45, 45, 45, 45 degrees, 45 degrees, and 45 degrees. So now you can see that the space between these what? Between the north and east. So we call this one northeast. We call this one southeast. We call this one southwest, and we call this one northwest. So if you count the cardinal point now, it's what now? 8. 1, 2, 3, 4, 5, 6, 7, 8. We can also divide it further to 16, but you don't need that. So let's just stick with these 2. Now, because this is what we are going to use. So when we talk about our compass bearing, we are talking about the north, southwest, and east, or northeast, southeast, and the rest of them. So in measuring bearing using two-digit bearing or cardinal points, you always measure with respect to north, south, west, or east. So one important thing you need to note under this is that if you have our cardinal point, you're measuring it now, and it's very, very key: north, south, west, and east. Are you with me? So since it's two-digit bearing, you measure from this point here, or go this way. Then also from the South Pole to the east, or this way. So if you look at what I have here, this is very, very important when it comes to measurement of bearing in compass bearing. So you see where the arrow is coming from. It's coming from the north going to the east, from the north going to the west, from the south to the east, from the south going to the west. So for this one, that's going to, we call it what? Northeast. South to the west, what? Southeast. So that's why I cannot say east-south or east-north, because I'm following the direction of the arrow, and that is the proper thing. Likewise, this is going from north to west, that would be what? Northwest. This one is going from south to the west, that would be what? Southwest. So if you are measuring bearing, provided it's compass bearing, this is exactly what we are expected to do in measuring the bearing. I hope that is taken. So let's now look at example, or how we can what? Put down bearing on what? On a space. So assume you have to sketch. Example. sketch the following. Sketch the following bearing. 1. North 65 degrees west. Number 2. South 48 degrees west. Number 3. North 14 degrees east. And number 4. South 87 degrees east. So if you are to sketch any of these, it's south 77 degrees east. So the first thing is what? You draw your cardinal point. The first thing is we draw a cardinal point north 65 degrees west. Draw your cardinal point, then label it north, south, west, and east. So here, north, west, you go to the space. Where do you have north? This is north, and this is west. Then 65 degrees. So definitely, you know that this angle will be here. But which portion are you going to put the 65 now? If you look at what I have here, I'm moving from north to what? To west. So it means the angle will be what? Outside, not inside. So I'm going to have something like this. So my 65 will be here and not here, because the instruction is that what? You move from the north to the west, not the other way around. So the 65 will be inside, not outside. Then in bearing, we use our eyes to gauge the measurement. It's not compulsory we use any ruler. So you know that 65 out of 90. So 65 will be bigger than 9. So the remaining portion here should be 25. So that is the remaining portion here. But your main angle is what? The 65. So how do you get 25? You subtract this from 90, since everything is 90 degrees. So that's the sketch for the first one. For the second one, you do the same thing. South 48 degrees west. You sketch your diagram again, put in the cardinal point, north, south, west, and east. Now, southwest, go to southwest, southwest. So the angle will be here, southwest. So how do you now put it now? Is it going to be inside or outside? Following what you have here also, south to west. That is the arrow. So it means you are going to have it what? Inside as well. 48 degrees. South 48 degrees, and not this place. So the remaining portion should be what? Let's say 32 degrees, which will give us 90, or 42 rather. 42 degrees. That gives us 90 degrees. But your main answer is what? The 48 degrees. For the third one, I have what? North 14 degrees east. You draw your cardinal point as well. North, south, west, and east. North and east, we are dealing with north, so it definitely will be here. 14 degrees, north to east, not east, north. So, and it's 14, so it's going to be a very small angle. And if we are, be here, 14 degrees. So you can see, you use your eyes to gauge your angle. So when you subtract from 90, this should be 76, right? 08, yes, 76 degrees. But your main angle you are doing is what? 14, not the 76. Then last one, number 4 is what? South 77 degrees east. Draw your cardinal point as well. North, south, west, and east. So we have south 77 degrees east, southeast. Southeast will be here. Then it's moving from south to east, not the other way around. So 77. The angle will be bigger than the other portion. So 77 will be here, 77 degrees. And that's our point. So the remaining portion here should be what? That is 23 degrees in order to complete 90. So this is how you sketch 2-digit bearing. I hope that is clear. Let's now move to 3-digit bearing. So for our 3-digit bearing, here we'll be looking at what? 3 numbers or 3 figures. So in measurement of 3-digit bearing, we work in what? 3 figures. You work with three figures, that is 0, 0, 0 degrees, 0, 0, 7 degrees, or 0, 1, 5 degrees, or 2, 1, 5 degrees. So you see everything is what? 3, 3, 3 digits. So no north, no south, no west, no east. So that's why we call it what? 3-digit bearing. And you can interconvert. You can convert from 3 to 2 and from 2 to 3-digit bearing. So when we talk about 3-digit bearing, how do we measure it? The measurement is different from the one of compass bearing. So how do we measure for 3-digit bearing? Let's look at our cardinal point again. Start with the north, south, west, and east. In measuring 3-digit bearing, you measure it in the clockwise direction. You start from the North Pole and move in the what? Clockwise direction. That is the way the hand of the clock move. So you are starting from the North Pole, then you move in clockwise direction. So this is how you measure 3-digit bearing. Starting from the North Pole, then you move in the clockwise direction. So remember that each angle is 90, 90, 90, 90, forming 360. So anything you have to measure, you move it like that until it gets on this arrow or this curve, touches the line, connecting the line you have to what? The point you have to what? Sketch on the space. Let's take example. Example. Sketch the following bearings. Number 1, I have 0, 80 degrees. Number 2, 135 degrees or 139 degrees. Number 3, 205 degrees. Number 4, 327 or 325 degrees. All this you can see that there's not like northwest, south, east, and the rest of it. So here we have to sketch this. So how do we go about this? Solution. Let's look at it together. The first one is what? 0, 80 degrees. So you still draw your cardinal point as usual. Starting with the North Pole. Now remember that I said from here, going this way is 90, 90. So if you are starting from the North Pole, from here to here, this is east, west, and south. So it means 0, 80 degrees would be between north and east because that is 90 degrees. Are you with me? So it will not exceed this first part since you are moving in the clockwise direction following this diagram. So my 0, 80 degrees will go to this like this. And this is my 0, 80 degrees. Are you with me? So this is my 0. So I'm moving, look at where you stop. So that is our 0, 80 degrees. So the remaining portion here is what? 10 to complete 90. So this is how you sketch your 3-digit bearing. Now for the second question, I have what? 139 degrees. Do the same thing. North Pole, South, West, and East. 139, starting from the North Pole. Look at the first moving. That is what? 90. You now think of what is remaining to complete 139. That means you have 139 minus 90. You know you have completed 90 rotation. So to get the remaining portion, you subtract this 90 from this. So this gives us 9. Then 13 minus 9, that is what? 4. Are you with me? So it means that the remaining portion is what? 49. So the whole of this rotation here is my what? 139. But this portion is, this small portion is what? 49. Are you with me? So if 49 from 90, that gives us 1, then 8, that's 41. So I will still come back to this because you are still going to refer to it. That's why I'm putting them there. So my 139, starting from the North Pole until the line connecting this. And that's where you stop. That's 139 degrees. The third question, we have what? 205 degrees. You still draw your cardinal points. North, south, west, and east. Then we have to measure 205. Starting from the north pole, the same thing. This is 90. This is 90 again. That's 180, right? If I complete it, this will be 270, but I need 205. So 90, 90, that's 180. So to get the remaining portion, I will subtract 180 from 205. Not from 270. 180 from 205. No, I've completed this rotation. So it is rotation that you have completed that you subtract to get the remaining portion. So when you do that, this will give us 5. 10 minus 8 give us 2. So the remaining portion is what? 25. Sorry. So the remaining portion is what? 25. But this complete rotation like this is what? 205 degrees. Then the fourth one, we have to sketch 325 degrees. Number 4. 325 degrees. North, south, west, east. So we are moving the same thing. First rotation, that's 90. Second rotation, that's 180. Third rotation, that's what? 270. So automatically my 325 will be here. So how do I get the remaining portion? You subtract the one you have completed, 90, 90, 90. That's what? 270 from 325. So I have 325, 270. This is 5. 12 minus 7, 5. That's 55. 55. So this is the complete rotation like this is my 325 degrees. Why this small portion is 55 and the one outside here is going to give us 40 or 35 to complete 90. So this is how you sketch 2-digit and 3-digit bearing. Let's now look at conversion from 2-digit to 3-digit and from 3-digit to 2-digit bearing. I'm still going to use the same example on the board. Let's now look at conversion of 2-digit bearings to 3-digit bearing. Example, convert the following compass bearing to 3-digit bearing. North 65 degrees west and south 48 degrees west. Let's just stick with these two. It's on the board already. So let's look at the conversion. First one, draw your cardinal points. North, south, west, and east. Northwest 65. You said the north to west, so the 65 will be here. While the remaining 25 will be what? Outside. So for 2-digit bearing, this is north 65 degrees west. Now in 3-digit bearing, look at it, it's still on the board. Our measurement is what? Is in the what? Clockwise direction. So you are starting from the north pole, moving until that line, that straight line that emanates from the center. So that means I'm going to move from that north pole in the clockwise direction until I get to that line that we have on the board. So from what you have here, this is a line here. So if I'm to take my measurement, I'm starting from here. This first rotation, that is 90. Second rotation, another 90. Third rotation, another 90. And the fourth rotation what ends what? Here, which is 25. So the conversion of north 65 degrees where is going to be what? 90 plus 90 plus 90 plus the smaller angle, which is what? 25 degrees. And that will give us 270 plus 25. Which is what? 295 degrees. So it means that my north 65 degrees west is equivalent to 295 degrees. No north, no south, no west. So this is conversion of 2 to 3. Let's look at the second one. South 48 degrees west. South 48 degrees west. North, south, west, and east. Southwest. This is southwest here. So, and we have it on the board as this way. This is my 48 degrees. The remaining portion is 42. Are you with me? So, this is for 2D. Then for 3D, you still follow the same steps. Move in the clockwise direction. This is 1. This is under 90 plus where it ends here. So So you are stopping at this point. That's 48. So therefore, my south 48 degrees west is going to be what? 90 plus 90 plus 48. And that gives us 180 plus 48, which is 1228. 180 plus 48, that will give us 228 degrees. So that is how you convert from 2 to 3 digit bearing. Conversely, conversion from what now? 3 to 2. Conversion from 3 to 2. So let's look at this example that we have here. Assume we have to convert this 3 digit bearing to 2 digit bearing. 139 degrees. Where is 139? This is my 139. And this is my 3 digits here. This is 49. This is 139 degrees. So look at the movements. This is 41. So in converting the 139 to 2 digit, which means what? You look at that where the line stops. This is where it stops. The arrow stops, right? Then you know that in 2 digits you are measuring from what? South to east. So the remaining portion here, which is 41, is what? South to east. So this 139, the equivalent is what? South 41 degrees, and that's the essence of looking for the remaining portion there. So this is south. This south 41 degrees is equivalent to my 139 degrees. Also for 205, look at 205. This is 205 here. Measuring like this is 25. The remaining portion here is 55 or 65 degrees. Yeah, 65 degrees. So if I'm to convert this 205 to 2 digit bearing, 205 to 2 digit bearing, you go to where that line is. This is southwest. So since the movement is southwest, the angle I'm using is what? That angle which is inside, not the one outside. Because if I use the one outside, it means I'm measuring from west to south. So since I'm looking from south to west, it's going to be what? South 25 degrees west. Then the last one, this 325, converting also. This is my 325 up to this point. So, and the remaining portion is 35. So my 325 in 2 digit bearing is going to be what? North to west. And what angle here? Since you are moving this way, it's going to be what? This one, this 35 north. So this is going to be what? North 35 degrees west. So this is how you convert from 2 to 3 and from 3 to 2 digit bearing. Let's now look at location of points. When you talk about location of point on a plane, here you are looking at what? The distance between 2 points. Location of point on a plane. Now, assuming the bearing of A from B is 060 degrees. We are now asked to find the bearing of B from A. So bearing of A from B is 60. Find the bearing of B from A. So the first thing is what? You draw your cardinal point as usual. North, south, west is here. You have 2 points here now. One is A, one is B. So when they say the bearing of A from B, the preposition from has something to do with what? The point B. So it means if you have to put it on your space, the B will come first before A. Just like somebody asks, where are you coming from? I'm coming from, that location will come first. So the bearing of A from B, it means this will be your B first. Your B will come first. So the bearing of A from B is what? 060 degrees. 060 degrees fall in the what? In this portion here. 060 degrees. So when you draw that line, then you connect it together. This will now be my A. Are you with me? From bearing of A from B, the B will come first, the 60 degrees. Then, so if you use the concept of alternate angle, this angle is alternate to this. So if this is 60, this also will be 60. The remaining portion will be what? 30 from 90. So if this is 30, this also will be what? 30 degrees. So I've sketched the first statement, the bearing of A from B. This is the first statement. The second statement, when I ask to find the bearing of what? B from A. That means you are taking your measurement at what? At A. So in that case now, we are moving in the clockwise direction, which is what? Using 3-digit method. So you start from the North Pole. 1, are you with me? 2, onto the line connecting the 2 points A and B. And which is line? Which is this line? Then 3. So you stop here. So it means that therefore the bearing of B from A is equals to 90, 90, and 60. Plus 90 plus 60. And that's 180 plus 60, which is 240 degrees. So that's the answer. So the bearing of A from B, that is, you are taking it from B. Then the bearing of B from A, you are taking the measurement from what? At A. Let's look at another example. Example 2. Given that the bearing of Ade from Olu is 175 degrees. Find the bearing of Olu from Ade. So I'm going to use the initials to represent the points. Now let's use A as Ade and O as Olu. So they say the bearing of Ade from Olu. So I'm going to put the cardinal point again. North, south, west, east. Bearing of what? Ade from Olu. It means I'm going to write Olu first. So what is the bearing? 175. This is 90. Right? This is 180. So, and I need 175. So it means God, the remaining portion was 85. That is 180 minus 175. And that gives us what? 5 degrees. So the remaining portion here will just be what? 5. So this is 175 degrees. This is 175. So if this is 5, then this one will be what? 85 degrees. And this is 90. So that captured it. So after you draw another cardinal point. Always ensure that after you finish drawing the first one, you draw the cardinal points to complete. So if this is 5, this also will be 5. If this is 85, this also will be what? 85 degrees. That's what we call alternate angles are equal. Now this is now Ade. So the question I say, well, find the bearing of Olu from Ade. It means you are taking the measurement what? From Ade. So you start from the North Pole and move in the clockwise direction until the line connecting both Olu and Ade, that's where you stop. So you start from here. This is 90, that's one rotation, 90, second rotation, 90, third rotation, and 85. You stop here. So it means, therefore, the bearing of what now? Of Olu from Ade is 90 plus 90 plus 90 plus 85. And that gives us 270 plus 85. This is 355 degrees. 355 degrees. So this is how you locate 2 points, or locate one bearing from the other. So if all these are very clear, then we can now move to connecting 1 or 2 points or 3 points and looking for the distance between them. So let's look at the question. We have 3 points P, Q, and R on a horizontal plane. That means this is the horizontal plane. The 3 points are located on this plane, right? Point Q is on a bearing of 120 degrees at the distance of from P. So P will come first. So let's say this is my P. This is my P. The bearing of Q from P is 120 degrees. So this is, sorry, because of the space, let's take it down a bit. This is my P. This is my P. And they say the bearing of what? Q from P is 120 degrees. So this is 90, remaining 30 to complete 120. So this is what I have here. So this is my Q. This will be my Q. So the distance is what? 80 meters. This is 120 degrees. The portion here is 30 degrees. Okay? So at this point we have our Q. So let's continue from there. Then point R is on a bearing of 0.45 degrees and a distance of this from Q. That is R from Q. Bearing of what? 0.45 degrees. 0.45 degrees from Q. So we have, let's see, this is our R. 0.45 degrees. From where? From Q. So this is 0.45 degrees. So this will be alternate to this. I hope you are with me. This is my R. Distance is what? 180, 150 meters. And this is 80 meters. So this is the diagram. Then you connect these points together. From this diagram. So this portion here we don't know. Let's call it X to form a complete angle here. Now, if this is okay, there's no even way you can bring it together because this portion here is 30, this will be 60 by implication. So if that is 60, then this 60, this will be 60 degrees. So the whole of this angle is 125. That is 60 plus 45. That gives us 60, 40. Sorry, 105 degrees. 105 degrees. So that's the angle there. So, and this is the diagram. So let's now look at what we are asked to do. The first question says we should find the distance between PR. So that using cosine rule. So using cosine rule, the distance PR. So let's call this small q, this is small r, and this is small what? P. So we have q squared is equals to p squared plus r squared minus 2pr cos q. That is q squared is equals to p squared is what? 150 squared plus 80 squared minus 2 into 150 into 80 cos 105. And this will give me q squared is equals to 22500 plus 16 minus 300 times 80 4,000 times cos 105 minus 0.2588. So this will now give us q squared is equals to the addition of these two, 24100 minus times minus plus 62 11.66. That gives us q is equals to square root of 30311.66. So we take the square root of that value, 64.10244. So the question says to two significant figures. So our Q is equals to 170 meters. The two significant figures. So the second part of the question, we are asked to find the bearing of what? P from R. Bearing of P from R. So we take it from the North Pole. This is it here. Until you get into P. P from R, starting from the North Pole until it gets to P. So we're having 90, 90, 45 plus this internal angle. So we need to get this angle. Let's call it angle theta. So to get that angle theta, we use what? Sine rule. So by sine rule, I have sine R divided by small r is equals to sine Q divided by small q. So sine r, that is sine theta, over small, that's 80, is equals to sine q, that is sine 105, divided by our q, which is 170. So cross multiply, I have sine theta is equals to 80 sine 105 over 170. So our theta is equals to arc sine 0.4553. So the inverse of that angle, that gave us 27.036 degrees, and that gives us approximately 27 degrees. So therefore the bearing of P from R is equals to 90 plus 90 plus 45 plus 27. That gives us 180 to 70. 180 plus 72. And that gives us 252 degrees. And the last part of the question, they said how far west of R is Q? How far west of R is Q? This is R on the eastern part, so this is Q on the west part. So you take it from this point here, then connect it to this point. So this is what I'm looking for now. Let's call it N. So I'm looking for what? NR. So looking at that triangle, this is what we have here. This is Q, this is N, this is R. This angle is 27, this is 150. So I'm looking for NR. So using your SOHCAHTOA, I have adjacent over hypotenuse. So I have cos 27 degrees equals to NR over 150. So my NR is equals to 150 times cos 27. And that gives us meters, which is approximately 134 meters. So that will be all.